Hi friends, welcome to EK Lectures. In this lecture, we are discussing the following questions from the physics question paper of Karnataka SET 2020. A two-level quantum system has an energy eigenvalue E plus minus is equal to plus or minus under root E naught square plus E1 square. So here we have a quantum system which has eigenvalues this. So let me write lambda 1 is equal to plus under root E naught squared plus E1 squared, and lambda 2 equal to minus under root E naught squared plus E1 squared. Now the determinant of the matrix will be equal to lambda 1 times lambda 2, which is equal to minus of E naught squared plus E1 squared. Okay, so our matrix formed by this quantum system has a determinant minus of E naught square plus E1 square. Then trace of that matrix will be equal to lambda 1 plus lambda 2, which is equal to 0. So now the question is, this matrix is written in terms of Polish matrices, that means sigma x, sigma y, sigma z, and the identity matrix I. Which of the following does not correspond to Hamiltonian of the system? So this matrix, whatever matrix this gives you, H, should have a determinant equal to this particular value and trace equal to 0. So let us see the option one by one. In the first option, you have H is equal to E naught into sigma x minus E1 into sigma z. E naught, this is sigma x, minus E1 into sigma z, which is equal to this minus E1, E naught, and E1. Now what is the determinant of this particular matrix? Determinant equal to minus E1 squared minus E naught squared, which is equal to minus of E naught squared plus E1 squared. Now take the second Hamiltonian. So this is true, and let us check what is trace equal to. Trace of this matrix is equal to E1 plus minus E1 plus E1, that is equal to 0. Okay, so your option is A is correct. Now check the option B. H equal to E naught times sigma y plus E1 times sigma z, which will give you E1 minus I E naught plus I E naught minus E1, which is equal to E1, that is equal to minus E1 squared minus of I and I into I is minus 1 into minus 1 is equal to plus, so minus again E naught squared, which is equal to E naught plus E1, E naught squared plus E1 squared with a minus sign. And similarly here the trace E1 minus E1, trace is again equal to 0. So your option B is also correct. Now check the option C. H is equal to E naught into sigma y plus E1 into sigma x. E naught into sigma y plus E1 into sigma x. So 0 minus I E plus E1 minus I E naught plus E1. Now here trace is sum of this diagonal element, which is equal to 0. Determinant is 0 minus E1 minus I E naught E1 plus I E naught into E1 minus I E naught. A plus B into A minus B, that is equal to A square minus B square. I will get squared, so what you are getting is minus of E naught squared plus E1 squared. Again, your determinant is same, so option C is also correct. Now check the option D, which is H is equal to E naught times I, identity matrix, plus E1 times sigma Z. E naught times I plus E1 times sigma Z. This is what you are going to get. Here the trace is equal to E1 and E1 gets cancelled and E naught will remain. E naught will remain 2 times E naught. 2 times E naught. And what about the determinant? Determinant will be E naught plus E1 into E naught minus E1. So E naught squared minus E1 squared. So this is not true. So so the option D is the correct option, which does not correspond to the given matrix. So this is option D is the correct one. All others give you the same eigenvalues. Three-dimensional harmonic oscillator is in thermal equilibrium with heat bath at a temperature T. The average total energy of the oscillator. If the total kinetic energy was asked, kinetic energy is equal to half kBT. Then this is for one dimension. For three dimension, it is 3 by 2 kBT. This is only kinetic energy. Okay. Now, what about total energy? Total energy is nothing but twice that of the kinetic energy. So, which is equal to 2 into 3 by 2 kBT. So, that is equal to 3 kBT. So, kB, same, K, Boltzmann constant. So, your option is B.